Good morning, all. This is Henry from ASTEM Tutoring, once again with a short video lesson. Today's topic will discuss something you may be familiar with, the flash for a flash photography, like when you take a photo and at nighttime and you need a flash to provide illumination as the photo is snapped. Well, how does that work? What's the electronic circuit theory behind that? That is what we will discuss in today's video lesson. So let's head over to our handy dandy whiteboard. What's going on in something like that is that a capacitor is charged up through a circuit, and then when the flash is needed, it is discharged rapidly through a light bulb or an LED, providing a bright flash to illuminate the scene and so that you can take a photo in dim light, for example, at nighttime or in a dark club. So this is a simple RC circuit for charging a capacitor. When this switch is closed, current will start to flow and charge the capacitor. The expression for charge on the capacitor is CV times the quantity 1 minus e to the power of negative t over RC. RC is the product of the resistance and the capacitance. It is also called the time constant of this circuit. You can see from this that if we carried out t to infinity, then the e to the power of term would drop out to 0, and the final charge on the capacitor would be CV, the capacitance times the voltage applied, which should be familiar to those of you who have learned a little bit about physics and capacitors. What if we wanted to find the current at any given time? Current is defined as the derivative with respect to time of the charge. So we would get, let's see, first of all, we can multiply this out to get CV minus CV e to the negative t over RC. And we're taking the derivative with respect to time of this quantity. Well, CV is a constant, so that drops out when we differentiate. This term here, though, has an e to the power of, so we will use what we know about derivatives of an exponential. So we would get CV over RC times e to the negative t over RC. Okay, so let's look at that. How did I get this? Well, the coefficient of t here, negative 1 over RC, comes out and gets multiplied by the leading coefficient. Negative times the negative is a positive, so the leading coefficient becomes CV over RC, and then we still have e to the negative t over RC. So let's think about what this tells us physically. At time t equals 0, the instant you close the switch, that means the instantaneous current is CV over RC. As time progresses, the current drops off, eventually leading to 0 as t approaches infinity, which makes sense because once the capacitor is fully charged, current will not flow anymore. So from an intuitive perspective about what's physically happening, this expression makes perfect sense for the current through a capacitor that is being charged through a resistor. And again, this is the sort of thing that happens when you charge a capacitor so that you can have a flash for your flash photo. This concludes today's lesson. This has been a short discussion about charging an RC circuit. If you'd like to learn more, I'm available for hire as a private tutor. You can find my contact information in red up the top center of the whiteboard. The first 1 hour lesson is free for all new students. Try before you buy. You take no financial risk just to try me out. The burden of proof is entirely on me to demonstrate outstanding service in helping you succeed. And as a thank you for watching all the way to the end of today's lesson, when you contact me, please mention the code FREEBOOK, and I will give you a free copy of my book, Smart Suggestions for Student Success, at our first meeting. I wrote this book in an effort to help students, and particularly high school students and college students, to succeed in school, work, and life. Also, this book is available for purchase on the Barnes & Noble website, so if you just want to buy the book and read it without contacting me, you can do that as well. I hope you enjoyed today's lesson, and I'll see you next time. Thank you. Bye-bye.